Welcome back. The origin of continuous X-rays. Some high velocity electrons penetrate deep into the atom, and deep into the atom of the target material, and these electrons are attracted by that nuclei, wherein which the electrons gets deflected, and the deflection is as shown in the figure. So here you can see, and this is the electron beam coming from the filament having larger kinetic energy or very large velocity, and hence it penetrates deep into the atom of the target material, during which it gets deflected because of the influence of the nucleus. Because of the influence of the nucleus, it gets deflected, and during this deflection, it loses its energy, and because of which the velocity will be reduced, and hence we say that the X-ray will be retarded. And because of which X-rays of continuous wavelength is produced, right? And this is known as continuous spectrum. And this spectrum has a sharply defined short wavelength limit, that is lambda minimum, which corresponds to maximum energy of the incident electrons. Now, let the velocity of the incident electrons varies from v to v dash. Let v is the initial velocity of the electron, and v dash is the velocity of the electrons after deflection, and this is before deflection. And during the passage of the electron through the atom of the target material, it loses kinetic energy, and that is given by half mv square minus half mv dash square, that is equal to h nu. This is the change in kinetic energy of the electron when it passes through the atom of the target material, where h nu1, h nu2, h nu3 are the energies of different photons emitted by the electrons. When the electron is completely stopped within the atom itself, within the atom of the target material, then v dash become equal to 0. The final velocity will be 0. In the sense, all the energy of the electrons will be lost, and which appears in the form of a single photon of energy h nu max. The X-ray photon of maximum energy is therefore given by half mv square is equal to h nu max. This is the total kinetic energy of the incident electron. There is no ejected electron because all the energy will be lost by the incident electron, and that will be emitted in the form of h nu max, that is energy of the photon. If the electron is accelerated through a potential difference of v volt between the cathode and anode, if v is the potential difference between cathode and anode, and if the electron is accelerated through this potential difference, then half mv square is equal to ev, where E is the charge of the electron and V is the potential difference maintained between the cathode and the anode. But half mv square is equal to h nu max, therefore h nu max is equal to ev, or nu max is equal to ev by h. Also, nu is equal to c by lambda. Therefore, hc by lambda minimum, if nu is maximum, then lambda will be minimum. Hc by lambda minimum is equal to ev, or lambda minimum is equal to hc by ev, where h is Planck's constant, c is the speed of the electron with which it is moving, E is the charge of the electron, and V is the potential difference between the cathode and the anode. So substituting the values of hc and E and simplifying, we get lambda minimum is equal to 1.24 into 10 power minus 6 by V meter, or in terms of angstrom, it will be 12,400 by V angstrom. Lambda minimum is independent of the material of the target, and it depends only on the potential difference between the anode and the cathode. Larger the potential difference, smaller will be the wavelength, Smaller the potential difference, larger will be the wavelength. And the wavelength of continuous X-rays varies from a certain lambda minimum to infinity, and therefore it is known as the continuous spectrum or continuous X-rays. Thank you.